Good morning, Nana, all of you. Today we start continuation of the LFUs last 9th, 10th, 11th, 12th, 13th. 5 problems are there. So 9th question number 9. So if there is an integer, question number 9. If there is an integer, then show that z power 2n minus 1 by z power 2n plus 1 equal to I tan n theta. If z equal to cis theta, then show that z power 2n minus 1 by z power 2n plus 1 equal to I tan n theta. Just given that z equal to cis theta, so substitute in numerator and denominator, then you simplify it, then value is I tan n theta. So first write as z equal to, then write z power 2n equal to, all those simplify one by one, we have to simplify. Z equal to cis theta is given. So z power 2n equal to write as cis of 2n theta. So why? Because the power goes to angle cis theta whole power n. Cis theta whole power n nothing but cis n theta join with its augmentor. So that is why we can now simplify the expanded form is z power 2n equal to cos 2n theta plus I sin 2n theta. Expanded form I sin 2n theta. Next goes to numerator, that is NR means numerator, that is z power 2n minus 1, that is cos 2n theta plus I sin 2n theta minus 1. So now formula as write as cos 2 theta, formulas are two terms are there in terms of sin, in terms of cos, that is 1 minus 2 sin square theta, and another is 2 cos square theta minus 1. Trigonometry formulas are there. So in first year already we learned. So cos 2n theta now replace as to, this as to 1 minus 2 sin square n theta plus I into 2 sin n theta, sin 2 theta formula. 2 sin n theta cos n theta minus 1. Why? Because sin 2 theta formula. 2 sin theta cos theta. General formulas, trigonometry formulas. So now here substituted, this plus 1 minus 1 will get cancelled. Then you get 2 sin n theta is common. Then write as minus sin n theta plus sin n theta is 2 sin n theta common. So remaining I into cos n theta. Plus 1 minus 1 get cancelled. So now always we observe that I is don't always associated with the cos. So now simultaneously it associated with sin only. So this has to eliminate that. So that's why we are writing this as to minus 1 you think. So I square equal to what? Minus 1. This is the basic formula. So minus 1 here. This minus 1 I am writing 2 sin n theta into I square into sin n theta plus I cos n theta. Now I also common, then 2I sin n theta into cos n theta, I common outside, plus I into sin n theta. So this is for the value z power 2n minus 1. So what is given? Z equal to 6 theta is given. Z power 2 is nothing but 6 of 2n theta. Now Z power 2 in expanded form is cos 2n theta plus I sin 2n theta. Now numerator, that is Z power 2n minus 1. Just adding both sides by minus 1. So that is cos 2 theta. In terms of sine, I am writing 1 minus 2 sine square n theta plus I into sin 2 theta formula, that is 2 sin n theta cos n theta minus 1. So plus 1 minus 1 get cancelled. Now common in both terms are 2 sin n theta common, that is minus sin n theta plus I cos n theta. But here minus don't always associated with I with sin cos. Should be in sin only. That's why I am writing here minus 1 is there now. So minus 1 nothing but we have to write as I square. I square sin n theta plus I cos n theta. So from both terms I also common. That's why I common outside 2I sin n theta into cos n theta plus I sin n theta. This is the value for numerator. Similarly find out by z power 2n plus 1. Same thing. Just I am writing in this next page. So z power 2n plus 1, that is cos 2n theta plus I sin 2n theta plus 1. Adding both sides plus 1. Before minus 1 added. So that is now writing the form of. So then now substituted 2 cos square in another formula. 2 cos square theta minus 1. But in terms of 2n is there. So 2 cos square n theta minus 1 plus I into sin 2n theta nothing but 2 sin n theta cos n theta plus 1. Now plus 1 minus 1 get cancelled. So nothing but now common as 2 cos n theta is common. So 9 remaining cos n theta plus 2 cos n theta common, then means I sin, I is there, sin n theta. So this is the value for z power 2n plus 1. No need to before problem, just it is I is associated with a sign only. So there is no change. Only for before term. Therefore now in the question it is given z power 2n minus 1 by z power 2n plus 1. That is meaning that 2i, what we got, 2i sin n theta into cos n theta plus I sin n theta divided by 2 cos n theta into cos n theta plus I sin n theta. Then what will I get? This both terms should be cancelled and 2 get cancelled. Then I into sin by cos nothing but I tan n theta. It is hence proved. So that is the question it is given to prove that z power 2n minus 1 by z power 2n plus 1 equal to I tan n theta. Therefore z power 2n minus 1 by z power 2n plus 1 equal to I tan n theta. So now next in before what we have done, z equal to 6 theta, z power 2n is 6 of 2n theta, z power 2n expanded form. Once write cos 2n theta in terms of sine terms, 1 minus 2 sine square n theta. Sin 2 theta, 2 sin theta cos theta, plus 1 minus 1 cancel, 2 sin n theta common, minus sin n theta plus I cos n theta will be remain. So that is nothing but I is not associated with cos, always in the form of I 6 theta form. So now here minus 1 is there, I am writing I square equal to minus 1. So this minus 1 as I square I have written. I square I have written. That's why we are this minus 1 is I am writing here I square. So that is I square means I as common. Next, so then 2I sin n theta into cos n theta plus I sin n theta. Similarly, in the next page I have completed z power 2n plus 1 cos 2n theta plus I sin 2n theta plus 1 plus 1 minus 1 cancel. 2 cos square n theta means 2 cos n theta common, then cos n theta plus I sin n theta. In the question is given numerator by this is denominator. dr means denominator. So numerator by denominator, these two terms will be cancelled. So 2 to cancel, I sin into sin by cos is I tan n theta. That's all. This is the question LAQs. It is very easy, just in the form of Cos 2 theta comma you should write here, that's all. Cos 2 theta in terms of one side, 2 sin n theta cos n theta, 2 cos 1 minus 2 sin square n theta, or 2 cos square theta minus 1. So next question, question number 10. Question number 10 I am writing in the next page. Question number 10. If alpha and beta are the roots of, if alpha comma beta are the roots of x square minus 2x plus 4 equal to 0, then prove that alpha to the power of n plus beta to the power of n equal to 2 to the power of n plus 1 into cos n pi by 3. So that is the question. It is given. So now write as solution. What is the question is given? Alpha beta are the roots of the equation x square minus 2x plus 4 equal to 0. Then show that alpha power n plus beta power n equal to that value. So first the given equation we have to solve. Why? Because it is a quadratic equation. Then you get two roots. That root should be alpha and beta. Then alpha to the power of the power increased by n and beta to the power of n. When both add, then you get that answer. That is the process. First simplify the given equation. Then what are the roots we have to get? Given equation is x square minus 2x plus 4. Directly factorization, the values are not coming. That's why we are going to, by using the formula minus b plus or minus root over b square minus 4ac by 2a. Whereas a equal to what? A equal to 1, b equal to minus 2 and c equal to 4. So then substitute x equal to 2 plus or minus root over 4 minus 4 into 1 into 4. That is by 2a, 2 into 1. So x equal to 2 plus or minus root over minus 12 by 2. So that means 2 plus or minus 4 root 4 3, that means 2 root 3 into I by 2. Now 2 as common. So then you get 1 plus or minus root 3i. 2 as common. So 1 plus or minus root 3i. So that is substitute in the formula. Then you get this one. So where now the roots given as the roots having quadratic equation. Now let the roots be two roots. So that it be named as alpha and beta. Let alpha comma beta are the roots of given equation. Therefore alpha equal to 1 plus root 3i and beta equal to write as 1 minus root 3i. Now by using alpha power n, the power in the question is given that alpha to the power of n and beta to the power of n. So alpha to the power of n, nothing but the power. First we have to simplify in the complex number is given now. So that's why we have to write now complex number as in the form of modulus amplitude form. So its modulus, that is 2, we get 1 by 2 plus root 3 by 2 into I. Why? Because I am writing 2. So modulus is root over x square plus y square, that is 2. Then you get 2. So alpha equal to 2 into, now write as in terms of cos, that is cos pi by 3 plus I sin pi by 3. This is the value for sin cos theta. Write any complex number in the form of modulus amplitude form. So that is 2 into 1 by 2 plus root 3 by 2 into I, that is 2 into cos pi by 3 plus I sin pi by 3. So that is the value. So now going to alpha to the power of n, you have to write alpha to the power of n nothing but, no, first write as alpha, that is nothing but 2 into cos pi by 3 plus I sin pi by 3. Alpha to the power of n nothing but power raised to n, that is nothing but cos n pi by 3 plus I sin n pi by 3. Why? Because it is in the form of Demoivre, the power goes to inside of the join with augment. Similarly, beta to the power of nothing but same thing but as to sign only difference, 2 cos n pi by 3 minus I sin n pi by 3. In the question it is given alpha to the power of n plus beta to the power of n nothing but in both terms 2 power n is common, write as cos n pi by 3 plus I sin n pi by 3 plus cos n pi by 3 minus I sin n pi by 3. So sin terms will be cancelled, then you get 2 to the power of n into 2 cos n pi by 3. So nothing but base are equal, power should be added, then you get 2 to the power of n plus 1 into cos n pi by 3. This is the value for alpha to the power of n plus beta to the power of n. Now hence proved. In the previously what we have completed, that is given question, it is equation, the quadratic form. By solving the roots, apply 1 plus or minus root 3i. So then the question it is given alpha beta are the roots of the equation means one of the root is 1 plus root 3 and another root is 1 minus root 3. Now it is a complex number. Now we have to change into modulus amplitude form. So multiply and divide by its modulus. So that is 2 into 1 by 2 plus root 3 by 2 and nothing but. So 2 into cos pi by 3 plus I sin pi by 3. So that is alpha. But power raised to alpha to the power of n. So now write as alpha power alpha to the power of n nothing but 2 to the power of n into, as per Demoivre's formula, you can write cos n pi by 3 plus I sin n pi by 3. Similarly, beta to the power of n nothing but 2 to the power of n into cos n pi by 3 minus, plus has to write as minus I sin n pi by 3. In the question it is given that therefore alpha to the power of n plus beta to the power of n. In both terms 2 power n is common, sin terms will be cancelled, 2 times of cos n pi by 3, 2 to the power of n plus 1 into cos n pi by 3. That's all. This is the question number 10. Now moving to question number 11. Question number 11. So all of you please make a note. So next question 11, 12, 13 are there. 11, 12, 13. 3 questions are there. Question number 11. Solve x minus 1 whole to the power of n equal to x to the power of n, where n is a positive integer. Where n is a positive integer. Positive integer. Solve means the roots for find out the values for x. So in the question it is given x equal to what? So x power n, x minus 1 whole to the power of n is equal to x power n. Solve means x equal to what should we have to write? So simplifying most important. So that is I am taking for to solve this the power should be eliminated. So that's why I am taking first x minus 1 whole to the power of n equal to x power n, taking nth roots on both sides. Taking nth roots on both sides. So nothing but x minus 1 equal to x, but into 1 I am writing. 1 means 1 to the power of 1 by n. 1 to the power of 1 by n means get cancelled, that I am writing r convenient. Into 1 I am writing 1. So taking nth power means 1 to the power of 1 by n I am writing. So in terms of x into 1 means I am in the form of cis form, that is always nth roots of unity means cis 0 whole to the power of 1 by n. So x into cis 0 nothing but cis of formula is none. Cis theta whole to the power of 1 by n nothing but cis of 2k pi plus theta by n, where k equal to 0, 1, 2, so on n minus 1. That is 2k pi by n is nothing but n, where k equal to 0, 1, 2, so on up to n minus 1. So that is x into expanded form cos 2k pi by n plus I into sin 2k pi by n, that is x minus 1. So x we have to find, that is x has to one side, remaining terms as one side, that is x common, then you get 1 minus cos 2k pi by n minus I sin 2k pi by n equal to 1. All x terms as one side, minus 1 and then go to that side, then x as common, 1 minus cos 2k pi by n minus I sin 2k pi by n equal to 1. Now simplify as 1 minus 2k pi by n and sin 2k pi by n. So that is in the form of formula, that is 1 minus cos theta formula. 1 minus cos theta nothing but 2 sin square theta by 2. And sin theta is nothing but 2 sin theta by 2 cos theta by 2. This is the formula. So now here in the form of 1 minus cos theta, this is sin theta form. So that is writing in the next page. So what we have completed now, x minus 1 whole to the power of n equal to x power n. Taking nth powers, that means power should be cancelled, then you get into 1. I am taking our convenience, but it is in the nth power means 1 to the power of 1 by n. 1 equal to nothing but in the cis form cis 0 whole to the power of 1 by n. It is in the form of cis theta whole to the power of 1 by n. So that is cis of 2k pi plus theta by n, where k equal to 0, 1, 2, so on up to n minus 1. So that is x into cis of 2k pi by n, that is 2k pi by n, write as simplified form. So where k equal to 0, 1, 2, so on n minus 1. X minus 1 equal to x into a cos of 2k pi by n plus I sin 2k pi by n. So that is why so that is cos 2k pi by n plus I sin 2k pi by n. Next x has to common, 1 minus cos 2k pi by n minus I sin 2k pi by n equal to 1. But it is in the form of 1 minus cos theta, that is 2 sin square theta by 2. Sin theta is nothing but 2 sin theta by 2 cos theta by 2, that simplified form. So I am writing in the next page, that is x into, that is x into 1 minus cos 2k pi by n, that is 2 sin square 2k pi by n, nothing but 2 cancel, sin case and 2 sin square k pi by n minus r plus we are got already, minus is there, so that's why we can write as sin 2k pi by n, that is I into 2 sin k pi by n into cos k pi by n equal to 1, that is x. So that in x into, in both terms we are simplifying our convenience to take the common part. 2 sin k pi by n is common, then write as sin of k pi by n minus I into cos of k pi by n equal to 1. So that is x is equal to, right, but it is in the form of I is there with sign negative is there, so that is why multiply on both sides, it's conjugate. Why? Because x have to, we have to write multiply on both sides with sin k pi by n. A minus b term is there, write as a plus b, that means sin k is conjugate. Sin k pi by n plus I into cos k pi by n on both sides. So multiply this terms with this term, 1 into this term. Total expression multiply on both sides. So that is x into 2 sine k pi by n into, now it is in the form a plus b into a minus b, that is a square minus b square. So that is sine k pi by n whole square means sine square k pi by n minus I square is there. So that is where you get minus 1, that is a square sine square theta plus cos square theta form. So that is that into 1 equal to 1 into this total term means sine of k pi by n plus I into cos of k pi by n. So now meaning that x equal to, we write that is sine k pi by n plus I into cos k pi by n divided by 2 sine k pi by n. Therefore, x equal to, write as separated, distributed, then you get 1 by 2 plus I into I by 2 into cos by sine nothing but cot of k pi by n, where k equal to 0, 1, 2, so on up to as n minus 1 terms. In terms of in both, firstly write down 6 theta whole to the power of 1 by n form. So what we have completed now here, 1 minus cos theta form 2 sine square theta by 2. So 2 to cancel. Minus I into sine theta nothing but 2 sine theta by 2 cos theta by 2 form. In both terms, 2 sine k by n common, sine k by n minus I cos k by n equal to 1. This term should not be in the like this, it is negative and with I is associated with the cos. So that's why I am multiply on both sides by because x we have to write always. So this should be simplified. How will you simplify? Means it is a minus b term, then a plus b its conjugate, then multiplying on both sides, that is sine k by n plus I into cos k by n. Multiply, that is sine square theta plus cos square theta. Why? Because I square is there now, minus 1. So becomes to plus. So this total x into sine 2k by n into the term into this term means 1 over and 1 into this term means same thing. So x equal to, multiply here in the right as denominator form, sine distribution, that is sine k by n common, cancel, get cancel 1 by 2 and I by 2 into cos by sine is cot k by n, where k equal to 0, 1, 2, so on up to n minus 1. This is the question. This is just this problem is some difficulty is there. So more times you have to practice. So then you get very easy. This type of questions, objectives, very easy. Like this methods, like the same pattern, the objective will questions will come. So the remaining question is 12th and 13th. 12th question is 12th question is just doing mathematical induction form, and 13th question is also very easy. 12th question is, show that for any real number theta, show that for any real number theta, for any real number theta, cos theta plus I sin theta whole to the power of n equal to cos n theta plus I sin n theta. So this has to Demoivre's formula. So that is we have to prove by. So this method always in the form of mathematical induction, very easy to solve this problem. So what is the method of mathematical induction? Are you remember or not? In first year we have completed. So that is first the terms is the first term is the first term we have to write, put n equal to 1, n equal to k and n equal to k plus 1. But it is in the question, it is given for any value of theta, n is a positive integer, n should be positive or negative or anything. Here is we have to take n equal to integer. Integer means starting with 0. So first I am taking, so the given statement, as the procedure of mathematical induction, let s of n be the given statement, s of n be the given statement, So that is S of n. So given statement as write as S of n. Put n equal to 0. Integer means starting with 0. That's why we had write as in mathematical induction put n equal to 1. But here n is a integer, positive integer means. So write as first n equal to 0. So the given statement that is S of n, that is cos theta plus I sin theta whole to the power of none. Always go through the mathematical induction method. Don't be take a big problem. I sin n theta. So now first it is a positive integer always. N should be integer means you should take 0 also you have to prove. First don't take n equal to 1 directly. First n equal to 0 also you have to check. If n equal to 0 first. If n equal to 0 means cos theta plus I sin theta whole to the power of 0 equal to cos 0 theta plus I sin 0 theta. So that is equal to anything to the power of 1 equal to 1. This is also 1. So that is 1. So that is in this expression is, so it is proved. So that is expression should be equal. Now go to the positive integer, put n equal to 1. First case n equal to, if n equal to 1. So let S of n, the statement that cos theta plus I sin theta, put n equal to 1 write as cos theta plus I sin theta whole to the power of 1 is nothing but, so write as cos 1 theta plus I sin 1 theta. Therefore, this term equal to cos theta plus I sin theta 1 to the power of, this also cos theta plus 1 theta. So both are equal. Therefore, S of 1 is 2. 1 theta nothing but cos theta plus I sin theta 9. So that's why both are equal now, both sides. So therefore S of 1 is true. Next, if n equal to k, suppose assume that 1 is 2, then go to S of 1 k, that is cos theta plus I sin theta whole to the power of k equal to, write as n as to k cos k theta plus I sin k theta. So there is no change in the expression, so that let it be S of k also true. Now go to third, assume that if n equal to k plus 1, so that is cos theta plus I sin theta whole to the power of k plus 1. So I am writing this as to in the form of a to the power of n plus 1 and splitting the term, that is cos theta plus I sin theta whole to the power of k into k term means same thing, that is cos theta plus I sin theta. So that is cos theta plus I sin theta whole to the power of k plus into cos theta plus I sin. But cos theta plus I sin theta whole to the power of k just now proved, that is cos k theta plus I sin k theta. Then here write as it is and then multiply. So first we have what we completed. Let S of n be the given statement. So that is as statement we have to write. Then proved by, if it is positive integer, so we have to take n equal to 0 also. First we have to write cos theta plus I sin theta whole to the power of 0 equal to cos 0 theta plus sin 0 theta, nothing but becomes to 1. So cos 0 is 1, sin 0 is 0. So that is why this is anything power 0 is 1. So 1 equal to 1. Therefore S of 0 value, don't write S of 0, it is 0. That is a positive integer. So integer means you have taken just next, if n is a positive integer, then you take as n equal to 1. N equal to 1 means same S of 1 is 2. And n equal to k means where n is there, you have to write k cos k theta plus I sin k theta. And in third part is n equal to k plus 1. Cos theta plus I sin theta whole to the power of k plus 1, splitting the terms. Cos theta plus I sin theta whole to the power of k into cos theta plus I sin theta. But in this value already proved that this value is this. So now substitute in this. So that is cos theta plus I sin theta whole to the power of k plus 1 equal to cos k theta plus I sin k theta into cos theta plus I sin theta. Just multiply, general multiplication, cos k theta cos theta plus cos k theta into sin theta into I plus I into sin k theta cos theta plus I square into sin k theta into sin theta. Now I square is nothing but -1. Then you write as cos k theta into cos theta minus sin k theta into sin theta as one side. In these both terms I as common cos k theta sin theta plus sin k theta into cos theta. So nothing but it is in the form first year trigonometry form cos A cos B minus sin A sin B, that is nothing but cos A cos B plus sin A sin B cos of A plus B, that is cos A plus B nothing but cos k theta plus theta plus this is cos A sin A cos B plus cos A sin B, that is sin of A plus B form, that is sin of k theta plus theta. So that is we can get cos of theta is common, then you get cos of k plus 1 into theta into I into sin of k plus 1 into theta. So therefore we can write as therefore cos of s of k plus 1 is true. S of k plus 1 is true. Why? Because in terms of k you can write as k plus 1, then by mathematical principle of mathematical induction, S of n is true for all n belongs to n as method of mathematical induction. First we have completed n equal to 0, n equal to 1, n equal to k, and then n equal to k plus 1. Next go to the negative integer also we have to complete. In why? Because integer means it should be positive or negative. So that's why remaining one step are there. Suppose n equal to, take it as, suppose n is a negative integer. Previously all those we have taken positive integer, just examine by whether it is negative integer also we have to prove. That is, let n equal to minus m. So then write as m equal to minus n. So why? Because I am taking negative as m in, no need to write negative term. That's why m equal to minus n I completed. Then is a positive. So that's why then substitute, therefore cos theta plus I sin theta whole to the power of n equal to cos theta plus I sin theta whole to the power of, write as minus n equal to minus m. That is we write as 1 by cos theta plus I sin theta whole to the power of m. So nothing but 1 by cos m theta plus I sin m theta. Just now we proved as per method, but I am writing this simplified form is cos m theta 1 by 6 theta form minus I sin m theta. Rationalizing, then you get this one only. So that is cos of, I am writing minus m theta. There is no cos of minus theta, cos m theta. That's why I into sin of minus m theta. I am writing here cos of minus theta cos theta plus, here write plus sin of minus theta minus sin. That's why I am writing like this. But minus m equal to write as n theta. So that is cos n theta plus I sin n theta. This also proved. Therefore we can write as cos theta plus, always cos theta plus I sin theta equal to the power of n equal to cos n theta plus I sin n theta. It should be for all n belongs to z. You have to write this step, very very important. So for all n belongs to z, that means integer, whether it is 0 or negative or positive. All those first as method by mathematical induction one of the process, and before we step write an n equal 0, firstly write. In lastly, negative integer also important. This is why, because n is we already take it as z integers. So that is why first positive integer, negative integer also take. So simplified form, then you get for all n belongs to z. So this is the question. Last question is there. Okay, just you practice that one. Okay, tomorrow I will explain another chapter. So practice more than the question in the example problem is there. You have to practice that is. Now the time is over. So that is why. Okay. So okay, now thank you.